Hi everyone, welcome to today's class. Today we will be doing second lesson from electric potential and capacitance. Last class we defined what is electric potential. I will give the definition once again. Electric potential at a point in an electric field is the amount of work done to move a unit positive charge from infinity to the particular point against the electrostatic field without acceleration. And we obtained the equation for electric potential. What was the equation? Do you remember? Potential V is equal to W by Q. What is this W? Work done to move unit positive charge from infinity to the particular point. Q is known as the test charge. And we learned potential difference between 2 points also. Okay. So the potential difference between 2 points is independent of the path taken to arrive from one point to the other point. What is the reason? We all know electrostatic force is a conservative force. So work done is independent of path taken. It depends only on the initial and the final positions. Okay. Today we will derive the equation for electric potential due to a point charge. Electric potential due to a point charge. Electric potential due to a point charge. So children, today we are deriving the equation for potential at a point due to a point charge. Okay. So this is a point charge Q. Imagine a distance, imagine a point P at a distance R from the charge Q. This charge is known as source charge. I name it as A. This point I name it as A. Now, I am moving a test charge Q0 from infinity. So this is the infinity distance. I have to move the test charge Q0 from infinity to the point P. And we can calculate the work done for that. And work done divided by Q0 will give you the potential at that point P. So I am taking another intermediate point, say this is N. Distance from the source charge to the N is Q is X. And I am keeping a test charge Q0 at that point N. Now, to find the potential, just I am moving Q0 through a distance dx. So we can calculate the work done. At the point N, what is the direction of electric field? Electric field direction is away from a positive charge. So this is the direction of electric field. And I am moving Q0 towards the charge. I am moving against it. Okay. So displacement is dx, but I am moving it opposite to the electric field. So I am moving the test charge through a distance dx against the electric field. Remember, we have to move the test charge without acceleration. Now I can find out the work done to move a positive charge, move a test charge. Q0 through a small distance. Dx. What is the formula to find out the work done? You know, dW is equal to F dot dx. This is the formula for work done. Here force and displacement are opposite. So I am writing F dx cos 180. You know cos 180 is -1. So F dx minus F dx. And again you can write electric field is the equation F by Q0. So what is the equation for force? Q0 into E. So you can write force as Q0 into E. So I am writing dW is equal to minus Q0 E into dx. And you derived the equation for electric field at the point P. Electric field, what was the equation? Just to recollect, E is 1 by 4 pi epsilon 0 Q by R square. Here distance is x square. So you can put here dW is equal to minus Q0 1 by 4 pi epsilon 0 Q by x square dx. So this is the small amount of work done to move the test charge through a small distance dx. But we are here moving from infinity to the point P. How you can find out it? So total work done is obtained by integrating. So you integrate the equation. So total work done is integral from where we are moving infinity. Lower limit is infinity, upper limit is to the point at a distance R, dW. Okay, so integral infinity to R minus Q0 1 by 4 pi epsilon 0 Q by x square dx. You can take the common terms minus Q0 constant terms by 4 pi epsilon 0 Q. Remaining is integral infinity to R 1 by x square dx. Okay. And here you have to remember the standard result in integration. 1 by x square dx is minus 1 by x. Integral 1 by x square dx. What is the formula? Minus 1 by x. Standard result in integration. So we can write the work done. This work done, I am moving from infinity to R. I can write W infinity R. What is the equation? Minus Q0 4 pi epsilon 0 Q. What is integral 1 by x square? Minus 1 by x. Now you have to substitute the limit of integration on the right side of the square bracket. Infinity to R. Next step, you have to put the limit. This minus outside the bracket, take outside the bracket. So it becomes plus 1 by 4 pi epsilon 0 q0 q into 1 by first upper limit. Put upper limit for x, 1 by r minus 1 by infinity. And you know 1 by infinity is 0. Therefore, what is the equation for the work done? 1 by 4 pi epsilon 0 q0 q by r. Now you can find the potential. Potential at the point is the work done per unit test charge. The equation you remember, V is W by Q0. So electric potential at that point is electric potential at the point V equals, what is V? V equals, what is the equation? We remember, you learned it, W by Q0. So you have to divide this equation 1 by 4 pi epsilon 0 q0 by q by r by q0. You are getting V equals 1 by 4 pi epsilon 0 q0 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 you can cancel. So what is the remaining? Q by r, 1 by 4 pi epsilon 0 q by r. So this is the equation for the electric potential at a point due to a point charge. We can compare the graph between electric field versus distance and potential versus distance. Okay. So as a note, okay, I am comparing graph between electric field versus distance and potential versus distance. I will draw it in one single graph. You know the equation for electric field, E equals kq by r square. E is proportional to 1 by r square. And V is, now you obtained kq by r. V proportional to r, 1 by r. See the relation. Electric field is inversely proportional to square of the distance. Okay, power of r is 2 in the denominator. Electric potential is inversely proportional to r. Let me draw the graph. Okay, in a single graph, I am drawing two for the two cases. Y-axis, you take E or V. X-axis, R. Okay. If I draw electric field versus distance, this is the graph. Now you see potential is 1 by inversely proportional to 1 by r. Electric field is inversely proportional to 1 by r square. So if I draw a potential curve, I draw it with a different color. That potential versus distance curve will be like this. See, it will be less steeper. Why? E proportional to 1 by r square, power is 2. V proportional to 1 by r only. So potential versus distance curve is less steeper than electric field versus distance graph. This you have to remember, very important. So we have derived the equation for potential due to a point charge. Potential is electrostatic potential is a scalar quantity. So if there are many charges, how will you find the total potential? That total potential will be equal to the algebraic sum of the individual potentials due to each charge. So we can write the equation for potential due to a system of charges. Potential due to a system of charges. Okay. So imagine a system of charges, many charges. So this charge say Q1. This charge is a Q2. This charge is a Q3. So imagine a point P here. We are going to find out the potential at the point due to all these charges. So all these charges, there will be a potential at the point P due to all these charges. Q1 distance I take as R1. Say R1P. Q2 distance from R2P I take as R2P. Q3 distance R3P. So here there are three potentials. You have to take the sum. First potential V1 due to charge Q1. Second V2 plus V3. So what is the total potential? You have to take the algebraic sum. V equals V1 plus V2 plus V3. V1, you know the equation. K Q1 by R1P. V2 K Q2 by R2P. V3 K Q3 by R3P. So what is the total potential V? Take K constant. Q1 by R1P plus Q2 by R2P plus Q3 by R3P. So if there are n charges, you have to add more terms. Q1 by R1P plus Q2 by R2P plus Q3 by R3P plus Q4 by R4P plus etc. plus n. You have to take the algebraic sum. Okay. So this derivation is very important. Okay. And we will do a numerical based on this potential. I will give you a question from textbook. Okay. From your textbook, exercise 2.1. See, two charges, 5 into 10 raised to minus 8 coulomb. Read the question first carefully. And minus 3 into 10 raised to minus 8 coulomb are located 16 centimeter. First to read the question, understand it, visualize, draw the necessary diagram, apply the formula. So these are the steps for solving numericals. Okay. You have to read the question, understand it, identify the variables, think about the formula. Okay. At what points on the line joining the two charges is the electric potential zero? Take the potential at infinity to be zero. So I'm drawing the two charges. You visualize and draw. There is a charge Q. This is given as 5 into 10 raised to minus 8 coulomb. Another charge Q2. This is Q1 and Q2. Minus 3 into 10 raised to minus 8 coulomb. What is the distance between them? 16 centimeter. See the question, at what points? So points is plural. There will be more than one point. Keep in mind. On the line joining the two charges is the electric potential zero. First case, suppose potential is zero at this point. I name it as P. Take the distance from Q1 to that point as X. So what will be the remaining distance from Q2 to P? The remaining distance will be 16 minus X. So at the point P, we just learned total potential is algebraic sum of the individual potentials. At the point P, potential is 0. Okay. So first case, we see that Vp is 0, right? Vp, there are two potentials. Potential due to Q1, that is V1 plus potential due to Q2, that is V2. Then potential at the point P, we put as 0. So 0 is equal to V1 plus V2. 0 equals, what is V1? Potential at the point P due to the charge Q1. You know the equation. K Q1 by R. What is the distance from Q1 to P? You put as X plus V2. What is V2? Potential at the point P due to the charge Q2. So equation is K Q2. What is the distance from the point charge Q2 to the point P? 16 minus X. It is given at what points on the line joining the two charges is the electric potential 0. This potential is 0. So what we can write? We can cancel that K. So now you put the charge values. Q1 is 5 into 10 raised to minus 8 by X minus 3 into 10 raised to minus 8 by 16 minus X 0. You can take negative term to the other side. 10 raised to minus 8 also you can cancel. So 5 by X minus 3 by 16 minus X equals 0. Okay, or you can try take that 16 minus one term to the right side. So 5 by X equals 16 minus 3 by 16 minus X. Now you cross multiply 16 minus X into 5 equals 3X. Open the bracket. 80 minus 5X equals 3X. So you can write this gives you 5X take the right side. So 8X is equal to 80. So what will be X? X will be 10 centimeter. You divide it. X is 10 centimeter. This is from which charge? Q1. Okay. Now there is one more point. We let the point second point let it be here at this point. Say at the point N. Okay. In this case, what is the distance from Q1 to N? This distance you take as, say, S. Distance from Q2 to the point N you remember as S. Here also potential due to two charges will come. So we have to equate to 0. Case 2. V1 plus V2 equals 0. So what is V1? Potential at the point N from charge Q1. K Q1. What is the distance from Q1 to N? Q1 to Q2 is 16 plus S will come. So 16 plus S plus K Q2. What is the distance from Q2 to the point N? S equals 0. So K you can cancel. Now put the values of Q1. 5 into 10 raised to minus 8. 5 divided by 16 plus S. Plus Q2 is minus 3 into 10 raised to minus 8 by S equals 0. So you can cancel 10 raised to minus 8, 10 raised to minus 8. What will be the remaining? 5 by 16 plus S is equal to 3 by S. If you cross multiply, 5S equals 16 plus S into 3. On simplification, what you are getting? 5S equals 48 plus 3S. So 2s will be 48. So s is 24. So this s is from q2. So what will be the distance of the point n from q1? It will be 16 plus s is equal to 16 plus 24. It will be 40 centimeter. Okay. So these are the points at which a potential is 0. So you have to remember potential is a scalar quantity. Another important thing you have to remember is electrostatic potential difference between 2 points is independent of the path taken to reach the final point from the initial point, or potential difference between 2 points depends only on the final and initial positions of the charge. It is not depending on the paths along which they arrived from initial to final position. The reason is electrostatic force is a conservative force. Okay, this type of questions very important. Okay, children, thank you for watching the video. Share, comment, give your comments. Okay, we will see the next class. Okay, goodbye for today's class. Goodbye.